Super similar to last time, but now we're going to do the line of best fit with a calculator. So we're going to practice this over the next 2 days. We're going to be doing stuff with a calculator. So think about this question. So you're going to decide how strong is a linear relationship if the correlation coefficient is the following. So if it's 0.2, is that a really strong correlation coefficient? So does 0.2 show a really strong relationship? Remember, the closer it is to 1 or -1, this is really, really strong. So 0.2, no, it is not a really strong relationship. Okay, what about 0.4? This is where you kind of like, maybe I'm going to go with no. Because it's not quite like halfway to 1. It's really close, but it's not. I'm going to go with yes on the 0.5 because you're halfway to 1, and definitely yes. That doesn't even look like a yes anymore. On the 0.8. 0.8 is a really strong linear relationship. It's solid. Okay? So, most professionals will consider anything from about anything between 0.5, -0.5, and 0.5. They'll just throw out that. Well, -0.4 and 4.4. They'll just throw out that data. They're like, not a strong enough relationship. We can't actually consider this linear. Okay? So, next thing. Here's our calculator instructions. So, we are going to be doing a linear regression. Okay? So, our calculator instructions, we go to our calculator. We push second. This is the first thing you need to check. Then press the catalog button. It's the 0 button. And then you are going to go down until you find diagnostics on. It's down quite a ways. Just keep going. Okay, there's diagnostics off, diagnostics on. Hit enter. Hit enter. Okay, cool. It's done. It turned on diagnostics. Now, I want to go to stat. I want to edit. And in list 1, I would put all of my x values. In list 2, I would put all of my y values, and they need to match. Okay? Once you do that, you press stat, go over to calc, then you're going to go down until you see linreg. So right here it says linreg. Actually, no. This is the one you want. 4. Linreg ax plus b. That's the one you want. Okay, now press enter. Then you want this one to say L1. You want the X list to be L1. So mine doesn't say L1. So I want to make it L1. Then my Y list is L2. And then we're actually going to store our equation in the Y variables. Okay? So I'm going to hit vars, Y vars, function, Y1. That's where I want it to store. I want it to store in Y1. Then I would press enter and calculate. Because I have nothing in there, it's just going to send out an error. It's like, there's nothing in there. So I press enter and it sends out a list. So let's go ahead and make one of these. I was hoping it'd just send me to the thing. All right. So I'm going to go back into my stat menu. I'm going to edit my list. In L1, I'm going to put all of the prices of a shirt. So 50, 44, 41, 33, 31, 24.5, 20, and 14.5. Okay, now over here I need to make sure they match up. So 50 should go to 200, 44 should go to 250, 41 should go to 300, 33 should go to 380, 31 should go to 400, 24.5 should go to 450, and 200 should go to 20 should go to 500, and 1450 should go to 550. Okay, now I'm going to press stat again, go over to calculate. I'm going to find linreg, so right there, number 4. Now make sure that's L1, L2, and I want to store this equation in my y equals. So I'm going to push vars, y vars, function, y1. I'm going to press enter 2 more times. And here's all of my information. Now, one of the things it wants is my line of best fit. Okay, so my linear regression coefficient, or R, is negative 0.99. That is very, very linear. It's almost perfect. Okay, and then the line of best fit, see how it says A equals negative 9.912, blah, blah, blah. So my line of best fit is Y equals A, so negative 9.912, X being my shirt price. And then it says plus B. See how it says Y equals AX plus B? We're going to put plus B. So our B is 698.428. So plus, and I've forgotten it, 698.428. Okay, and this means that's the number of shirts sold, and that would be the price that decays every single dollar. Okay, so there's my linear coefficient, so this would be a strong negative. And that is my line of best fit, which if I graphed it would look something like that. It's not perfect, but it's good. All right, let's take a look at this one now. So I'm going to put all my data in. So I'm going to go to Stat, Edit. I have to come over here, go up, Clear, Enter. I'm going to put 3929, so 3,929, 4209, 7436, 7576, 8178, 9260, 12066, 17258, and 23852. Okay, and then on this side, I need to go ahead and clear this data. Then this one's 11, 11, 18, 20, 17, 26, 47, 41, and 61. Now see how they match up? They're all the exact same length. So now I'm going to press Stat, go over to Calc, I'm going to go to linreg. L1 is in the correct spot, L2 is in the correct spot, and I want to store my equation in yvars function in y1. Okay, so this time, the function that represents the line of best fit, I've got to write that down. At this point I should just make that, take over that side of the screen. All right, so the function that represents the line of best fit is going to be y equals 0.002. I'm going to put 0.00257 x, and then my b value is 1.20478. I'm going out a lot of decimals, but there's a reason for that. My correlation coefficient is 0.94, and then I can do more decimals if I want. That's a really strong positive correlation. So what is the expected fatalities for 40,000 accidents? Okay, so and then we're going to decide if this is interpolating or extrapolating. So first things first, I'm going to make my graph look like this one. So I'm going to go to I'm going to go to y equals, I'm going to go to my window. I'm going to make my x-axis go from 0 to 25,000. Actually, I want it to go to 40,000 because I want to do 40,000 accidents. And I want it to count by, looks like it's counting by 5,000s. Okay. Then I want my y-min to be 0, and it looks like it's counting all the way up to 60. So we'll go with 60. Actually, we'll go with 200, just in case we get outside that range. So I'm going to hit graph. So there's my graph. Okay. Oh, and I should have changed my y scale to 10 because it's counting by 10 in my picture. So graph. Okay. So that's the graph for my data. Now I want to find out what the fatalities are after 40,000 accidents. So I'm going to hit trace. Then I'm going to type in 40,000. And it tells me my Y value is 104.08. And if you look, my highest value is at 23,852 accidents. So is that in between my data, which goes between 3,929 to 23,852, or is it outside of that? It's outside, so we're going to say extrapolate. All right, the other one I want to check is 15,000 accidents. So I'm going to go back to my graph. I'm going to hit trace again. I'm going to do 15,000. And that one tells me it'd be 39.78. So it'd be about 40 fatalities. I should round to a nearest person. So 104 fatalities. And then with 15,000 accidents, there would be an expected 40 fatalities. And 15,000, is that between 3,929 and 23,852? Yes, it is. So this is interpolate. Okay? All right, now it's your turn. You're going to be looking at this. So you're looking at these entries for the race. And once you do that, then I want you to go ahead and do this one. This is also very similar. This one's the years and then the vertical drop of roller coasters. And once you're done with that, go ahead and write your recap. And you are actually done for today. Good job.